Hey everybody, welcome to the OpenUSD Insiders live stream. We are super excited for today's show. We have a couple of special guests, one veteran and one newbie. The newbie just waved, Josh. Hey Josh. We'll introduce both our guests in just a minute. We want to get started just by giving a quick overview. We're going to be covering NVIDIA Cosmos World Foundation models, which is for physical AI development. That's going to be the topic of this live stream. So if you're just tuning in now, we're going to circle back to the topic in just about a minute or so, a few minutes. We're going to talk about GTC really quick, and then we'll introduce our guests. Again, we're going to be talking about how the OpenUSD ecosystem is helping advance physical AI. So you're into for an exciting hour. We welcome people's questions, comments. Let us know where you're watching from, any kind of projects you have that you want to share. Feel free to use that live stream chat and engage not only with us, but other people watching. So anyway, this really exciting news, besides what we're talking about today, is GTC. It's right around the corner. We're just a little bit over a month away now. I hope people in the community are getting their tickets, getting their hotel rooms. We hope to see everybody there. It's going to be a really exciting week. I cannot speak enough about the benefits of attending a live event like GTC, not only to engage with developers from our team and other people's teams in the ecosystem, partners and the expo floor, but to see the live sessions, learn in the lab, get credits, accreditation. Really, really cool, exciting learning opportunity at GTC. Kicking off with also a fantastic keynote by Jensen himself. So we do hope that everybody can come. If you do come, let us know you're coming. We got some cool stuff planned for the community. We'd love to include you in that. You can reach out to me anytime on Discord or via email at martinvidya.com. So these are some of the topics we're going to be covering on the screen. OpenUSD, of course, physical AI and robots. That's kind of what we're talking about today. Industrial AI and digital twins. We've covered that a lot. Gen AI and advertising. You might remember great presentations last year from WPP, and spatial computing and XR. And I believe that there's some really fascinating labs on that specific topic. So there's something there for everybody. And then we also, like I said earlier, you have the ability to get trained and certified while you're at GTC. This cost is for the equipment and the people that are needed to set things up and make it work. But we hope you are interested in some of this stuff. And if so, let us know if you have any questions or problems or need something answered. That's what we're here for. So you can get us easily on the Omniverse Discord, which is discord.gg/NVIDIA Omniverse. Okay, so we are going to get right into things because we have a lot to cover in this hour. We have a great presentation set. Let me start by introducing my co-presenters here. Here, I go this side. Starting with Pranjali. Pranjali, this is your second time on live stream. Thank you so much for coming. Tell everybody a little bit about yourself.
Yeah, so super excited to come back here. Last time, I think I walked through an overview of Cosmos. So I am product marketing manager for Cosmos, and I bring these models to you all to get to experience these models, play around with it, and let us know how you find them. So yeah, that's me, and I'm gonna pass the baton to Josh.
Amazing.
Thank you, Pranjali. Thank you, Edmar. I always want to do that. It's off the bucket list.
You had it reversed, actually. I think
I didn't know.
So close.
Yeah, my name's Josh. I'm a product manager on Cosmos, the World Foundation Model Development Platform, which Edmar introduced. I joined NVIDIA about 3 years ago on the Omniverse team, and really excited with how we're sort of working really closely between all the efforts on Omniverse and Cosmos, and we'll be talking about that today.
Amazing. Well, thank you so much. This is Josh's first time on live stream, so we're going to go really easy on him.
Thank you.
Actually, let's do the opposite. Feel free to ask any question you like in the live stream. And that's what we're here for. So excited to see so many people joining. We're broadcasting now to not only LinkedIn, YouTube, but also X. Okay, so we wanted to actually start. Obviously, the title of this live stream series is OpenUSD Insiders. So I think let's start with kind of talking about how OpenUSD is connected to physical AI and Omniverse. And for that, I think Pranjali is going to go through some of the key points here.
Yeah.
So Pranjali,
if you can share the screen.
Yeah.
Yep. So
you share my tab here. Give me 1 second to switch screens.
Yeah, I'm gonna go through some boring slides, but just be there with me. We're going to make it really easy for you to understand how OpenUSD is at the core and so important. A lot of you have been working on Omniverse or know about it already. It's a platform for developing physically based industrial digitalization applications. So you can think about it as a feedback loop for all the AIs that are entering the physical world. When we talk about physical AI, then having this feedback loop is like at the core of building physical AI applications. So it's just not a tool. It's a platform that has all the technologies that supercharge other tools and let them connect together at one platform. So you can build all the graphics. You can think about it as a integration of design, CAD, and simulation industry ecosystem. And we have a lot of partners that are building a lot of cool techniques on Omniverse, like Siemens. We also have some tools and APIs from Adobe and Autodesk. So all sort of things that you want to use to build good 3D scenes for physical AI. And I think that's where the important stuff. You can move to next slide, Admar. Why we have these live streams on OpenUSD, because OpenUSD is kind of your. Admar, I don't have your next slide, so.
Here we go.
Oh yeah, so I think OpenUSD was the format that we are using for Omniverse. Omniverse is completely built on USD at its core. It's enabling easy and lossless interchange of 3D data between the rapidly increasing set of tools and simulators that support the entire Omniverse platform. So think about it, it's just not a 3D format, right? It's a universal framework that we are using to describe, compose, and simulate all your 3D projects in. So when you talk about it as a universal language, then you understand that it is irrespective of what you're using to build that 3D scene, it's going to be one format that you can take out from and like use a very good 3D scene. And I think Josh will talk more about it on why OpenUSD and why Omniverse is such a key for building world foundation models. But before that, I also want to talk about why we are doing this and what is physical AI. So if we move to next slide, I think this is a very concise representation. It doesn't talk the complete potential of physical AI, but you can think about physical AI as these are the models that will understand and modify the physical environments that we live in. Unlike language models, the models that are being built for physical AI will generate, actions that these autonomous machines can perform, whether they are robotics or autonomous vehicles. These models will generate their next action, predict how they react in physical environments, and help them reach to a potential where they can they can help in real physical environments for industrial AI. So physical AI is like the next big thing that super excited for keynote as well, because I think Jensen's favorite topic, favorite child right now is physical AI. And but this is not as easy as it sounds. So on the next slide, I hope those videos play. These are videos like robots falling in, humanoids falling off. But this represents the biggest challenge that we have today in building physical AI. The data strategy, the data collection is super costly, because you have these humans literally demonstrating everything and building that data set to train a robot to really behave like humans. It's not scalable. It's some of the time it's very labor intensive and costly, as you can assume. And training is one part of it, one challenge of it. Other challenge is to test. How do you test such a resource intensive model, or how do you deploy it in the real world to even test it out? So this is on the right side, you have like physical testing is danger. This is a funny clip. I wish it could have played, but this is a funny clip of humanoid just falling off the ground, and it shows how risky it is, how dangerous it is if someone is deploying it and testing it in real world. And all of it comes down to a challenge of not having enough data to train these models. And I think it's a good segue for Josh to cover, but what's better is Jensen talking about Cosmos. Sorry, Josh, didn't want to share it, but I think let's hear what Jensen has to say about it, and then we can move to Josh.
Okay, awesome. Okay, we have this great clip. We'll be back in 2 minutes, but this is super exciting from Jensen himself.
The next frontier of AI is physical AI. Model performance is directly related to data availability. but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
The next wave of physical AI is super exciting. Okay, so now we have a nice introduction by Jensen there. Josh, do you want me to share your screen now, or did you want to continue on the slides I have here?
I think we can go ahead and continue on the slides. Yeah.
Okay, gotcha. Okay, here we go.
You'll have to click.
Oh yeah, you can go ahead and just yeah, we'll click through as we go. Oh, that's fine. So yeah, that was amazing keynote video. It was really exciting to work on that with Jensen. As always, nobody communicates a vision as well as he does, and so many awesome people here at NVIDIA collaborated to put that together and help put the inference results from Cosmos into that sampling, and hopefully you really enjoyed it. And I can even answer some questions that you may have on anything that you saw there, since we had a big hand in helping out with that.
Awesome.
And so yeah, as Jensen said, Cosmos is purpose built for physical AI development. As Pranjali mentioned in the previous slide, a physical AI is any sort of physical autonomous system, be it autonomous vehicle or a humanoid robot or a robot arm or so on and so forth. And as a platform, being purpose built for this mission, we sought to handle some of those major problems that Pranjali spoke about, and these solutions are reflected in these components that are largely available and can even be found as of January 6th or 7th a.m. on Hugging Face. So that includes our World Foundation models. These include a diffusion model variety, an auto-regressive model variety, and there's different shapes and sizes and capabilities that we can talk through during today's live stream. But at the top, that's what we're offering there. And any of these foundation models can be built up upon with post-training, fine-tuning, this sort of thing. We've also launched our tokenizers on Hugging Face and GitHub, and these can all be pulled as well. And you can think of a tokenizer as a sort of like a codec. Ultimately, we need to train and inference efficiently with our transformer model architecture, and the only way to do that is to transform the higher dimensional video data into lower dimensional latent space and also decode it. And so our tokenizers play that role there. And then, as Jensen mentioned, we have our CUDA accelerated Gen AI accelerated video creation pipeline, which is really a petabytes of scale video processing, where we take the video that we need to train upon, and using various AIs and processes, we prepare it for high efficiency and effectiveness training in the platform.
Wow.
And I think then the last little thing that'll show up there, if you click one more time, I think is all of this is released with NVIDIA's guardrails, just to make sure that all of this technology can be used for the good, and we try to do a really good job of making sure that any sort of inappropriate use could be handled that way.
Amazing.
Next slide. And so Cosmos is trained upon millions of hours of domain-specific video data. This includes autonomous vehicle traffic scenarios, humanoid robotic situations that they may encounter in the field on the edge. It's 20 million hours of videos. That equates to 9,000 trillion input tokens, which is just an absurd
Huge
amount of information, which resulted in over 2,000 hours of training, and all of this was done on 10,000 NVIDIA Hopper 100 GPUs in our DGX cloud.
And sorry, I'm gonna take one question on the fly because there is a question of how it is different from the video generation models. I think the answer is this slide, the data strategy that we have for Cosmos, right? So although all models are great, everything is great, the purpose is different for Cosmos World Foundation model. Purpose is really to accelerate physical AI development, and the data strategy here of 20 million hours of physical AI data is the answer to that question. Sorry, Josh.
Yeah, and I maybe if you mention it, but this is all open source. This is all push to Hugging Face. This is a platform for others to build upon and accelerate their development with robotics and autonomous vehicles. Okay, next slide. And here's an abstract representation of our autoregressive model architecture. It's an LLM style model, scalable transformer. Some of its benefits include better control, reduced training loss, minimal visual artifacts, and higher inference performance. And just to create some distinction and contrast for those of you joining us of, how does an autoregressive model sort of work different from a diffusion model? This could be a complicated question to really unpack at a detail level, but abstractly, we think of the autoregressive model perhaps as a bit more causal, meaning cause and effect. Every frame that is predicted as a future frame is conditioned upon the past frames. So, for example, if you provided the autoregressive model with a 9-frame clip, frame 10, 11, 12 would autoregressively incrementally be produced sequentially as it goes along the timeline. Next slide. And with the diffusion model, here we're refining random noise into coherent video frames. Some of the key benefits include parameter efficient design, better temporal consistency, support for various resolutions and frame rates, and ultimately it does net a higher visual fidelity. And to kind of go back to how the autoregressive model was working, where it was conditioning itself upon the past frames incrementally, the diffusion model, you could almost think of it as diffusing a volume of noise conditioned with your text prompt or whatever the other modal inputs are, which is a volume of noise defined by your resolution, X and Y, against time, which is your Z. And then this volume of noise is essentially diffused in a single step, although there's obviously various layers of things going on there. But it's one way to help abstract them to understand what some of the differences are between the two models. And so it's probably worth talking briefly about some of the use cases that we see with these before we jump into the next slide. And we can just see here for a second. So that includes, so we're trying to build physical AI. We're trying to accelerate that development. And so how can we do that? Well, one option is in downstream tasks, perception models, policy models, say we need to improve object detection robustness on an AI model. Say it doesn't know what certain situations or elements are in the physical world. Cosmos can be leveraged as a synthetic data generator. And there's various ways you could go about this. You could be using text to video, text plus video to video, or we can condition it, which we're going to go over a lot in this call, where we use ground truth renders rendered out of Omniverse and then style transfer them vid to vid through Cosmos. And all of these can be really great for evaluating policy and also, yeah, like I said, SDG. So the second use case that we identified is leveraging Cosmos as a physical simulator, where it can also be fine-tuned to your product's robot or your company's product, which is a robot or autonomous vehicle or such. And then not only can it intake images or video clips or text, but also action and control signals could be passed to Cosmos as a physical simulator, and then it could try to predict future results based upon those. And then this is part of what Jensen was speaking to in the multiverse end of that keynote video, where we had the forklift driving many different possibilities, many different worlds that where it could have played out different actions. Essentially, what we're showing there is policy evaluation, the physical simulator, where we're leveraging that. And again, all that can also be done through Omniverse, where we're passing policy, simulating the policy in an abstract world, an Omniverse or a photoreal world, and then style transferring it with Cosmos. And then the last major use case that we're really excited about looking at in the future, as we work together with all of our partners in the community, is Cosmos as a vision, language, action, condition policy model, where we fine-tune, post-train Cosmos, take it further, replace the video output head, and replace it with a action or a policy output head, where instead of Cosmos outputting video clips or worlds, as we like to call them, it's actually inferencing action tokens. And so those are some of the top 3 use cases we're particularly excited about, and all of these models can be leveraged in such a fashion. Next slide. And so all of those use cases, for the most part, SDG probably is a little bit more of a gray topic. You know, we really want our partners in the community to take our foundation models, which is why we've made them open source with everything, all the tools needed to get started, including fine-tuning sample scripts, to take our models and fine-tune them to very much specifically the use cases, the domains, the products that the teams are working in. And here you can see a rough outline of what that post-training or fine-tuning pipeline can look like, where we've got our video data, we pass it through our video data curation pipeline. Everything we're doing here is leveraging the tokenizer. As we've got our world foundation models, and then using Nemo's open source SDK framework, you can do your training. And again, these sample scripts are passed and they're available on Hugging Face, usually I think right next to the checkpoints which they're associated with, and then they could be evaluated and tested. A lot of exciting announcements to come at GDC as we continue. I think we're just at the beginning, but Pranjali, you came off the mic.
Yeah, and I think while we are at this slide, maybe Josh, I don't know specific answer, but there is a question on how much fine-tuning data do we need, and I think it depends. And you can correct me, Josh, because I think it depends on the task that you're fine-tuning for, right? If that's a simple task, maybe you can get away with tens or like closer to 100 kind of images or videos. And if that's a more complex task that has multi-view, a lot of environment understanding, then you will necessarily need more data, right?
Right. Yeah, I think in terms of like, there's a lot of different ways there's a lot of different domains and specific edge cases that the models could be fine-tuned to. And then depending on how in-depth that training needs to be, will probably affect how much complementary fine-tuning data you need. But yes, ultimately, it's way less of a significant number compared to the amount of data we've trained into the foundation models. And a way to maybe abstract that, because I don't have like a really fine answer to that, because it can really depend, is, you can think of these foundation models as NVIDIA, took these foundation models all the way through elementary school, through high school, through college, maybe even got them their PhDs, and now they're available to join the workforce. And they need some training on site to join in and help help the development of physical AI. And that, in a sense, that amount of time association is the easier way to think about it. It's going to be a lot less time that you're going to need to spend fine tuning.
Yeah, and I think a good thing about having these models open is that you also have these fine-tuning codes open and available on our GitHub repository. So if you have any fine-tuning use cases, if you are wondering how can I try, is it good for me, is it friendly for beginners, I think you will only know when you give it a try, right? So go ahead and use those codes, go on our repository and explore. Yeah. Okay. Let's move on.
Amelia's been doing a great job posting these links in the chat. But if you are watching from your phone or something, not looking at the chat, I'm going to put it on the screen because it's pretty easy to remember. But that's the address for the GitHub for Cosmos, and I believe she also posted the Hugging Face, which I'm not going to put on the screen because that's not such an easy URL. I'll put it on really quick so you guys can see. Good luck typing that out.
Yeah.
But anyway, they're in the chat, so we'll put them in the video description as well.
Very cool. All right. Next slide. Yeah, and so here we're showing, physical AI is born in simulation, and the understand, physics are really important here, and so this is why we're showing this positioning of Omniverse with Cosmos, is because through Cosmos it has these years and years, you could even say decades of, ultimately solutions being provided for various physics simulations or solves. And so much of that is available in Omniverse and performs so well with Sensor RTX and our PhysX, and all of it being wrapped into this this great platform. Omniverse is really a great place to get started for simulating these physics ground truth scenarios, and then to help alleviate the pressure, where we actually want to generate these synthetic scenarios using these ground truth simulation solves. But then there's a huge amount of pressure, and this is still an area of research, and hopefully as we move into the future, we can continue to benchmark and make those results public about how to train perception models upon more realistic looking video clips versus perhaps more abstract or simulation looking renders that maybe you see on some of the samples on the left. And so Cosmos can help style transfer as a function these simulation renders to these photoreal results, and the hope there, and where the research is pointing us is that this will help with better accuracy, for example, in things like object detection and perception training. Next slide. And so Omniverse supports various inputs from anywhere from CAD to point cloud to generated 3D data and physical materials. It has Sensor RTX, physically based lighting. Everything is there provided as ground truth source, and then just again positioning Cosmos to do the video to video style transfer function. I know it says 3D there, but right now with the way we're integrating Cosmos, is it's a video to video function. So you don't actually need to like pass the 3D data to Cosmos per se. We're going to take renders out of Omniverse. Next slide. And here you see just another example. This was in the keynote, where in this sample we created a simple shader in Omniverse, and we assigned it to the root transform. This can also just be a shader that you replace the white.mdl with in your kit install, and that way you just have to switch between white mode. If you want to do this at home right now, you could do that. And it basically, you could think of it as instanced segmentation, where each element that's placed in the scene, or it's in this case, in this image, it looks like it's the original reference, not each instance per se, has segmentation, and then using canny edges, we're able to define the composition of the 3D space, and then Cosmos can leverage that to style transfer that to a more photorealistic result. So in this case, we're not conditioned upon the color data. The color data is actually helping to just define the edges of forms in the scene. Next slide. Okay. Maybe, but before we get to this slide, maybe we could jump to my screen, Edmar.
All right, everybody, close your eyes. Don't look at the screen.
Yeah.
Okay, you ready for your screen?
Spoilers.
I'm gonna make your screen a little bigger so we can see more. So I'm gonna bring us out
please.
for a minute. There we go.
Yes, apologies everybody. I have a very widescreen monitor. It actually wraps entirely around me. It's so wide, so it's probably garbling some of the text. But if you have any questions, I'm happy to read off what some of our prompt or parameters are in greater detail. But here we actually built this sample extension, and we demonstrated this at CES this past January, live on the floor. I was there. It was really fun talking with everybody. And basically what we have here is the graphics user interface that you see here is Omniverse. And inside the viewport, we've taken sort of a splattering of different types of content, and have done sort of a traditional layout of this content. So for example, you'll see for the walls and ceilings, we have a very sparse, rough LiDAR point cloud that we just converted to really rough mesh and geometry. We have some automotive vehicles that we inference through Edify 3D, which you can access online. And this helped us use generative AI to generate these really simple AI models, although you can even get much higher. But for this case, this is what we were looking for. And there's also some other examples of some CAD models we've brought in, TurboSquid type assets, you name it. We've sort of laid them out in this environment and used it to condition a result. And really what we're trying to show here is the power of Omniverse and Cosmos together, where I like to think of it as maximum control with minimum effort, where how can we free up physical AI developers to work in a specific appropriate level of fidelity in their simulation renders, and then make that jump to real using Cosmos so that our physical AIs can train upon it. And so we've got this viewport, like I spoke, and then over here on the right, you'll see a description of our prompt, where we've just generally described or given the direction to Cosmos of how we'd like to see this this abstract render interpreted and inferenced into a realistic result. And so it talks about things such as the scene captures a large open garage door from within an old warehouse with a worn and industrial aesthetic. And then it goes on to describe the various elements that we have in the scene, because that's what we're looking to see distilled back. And here you'll see a really nice result where it took all of that conditioning, the text prompt, plus the parameters that we set, and all of these will be exposed and improved upon as we iterate to provide this result. And this is actually a video, and as you saw in the keynote, all of those videos were made in exactly the same way. We generated the source videos, which often looked like this sort of candy colored style rendering of segmentation. And we simply animated objects or animated the camera and then inferenced the result. In this case, we simply just, because it's a demo, we just don't have the camera moving and this sort of thing, but it's actually a video clip that's being inferenced here. And so, yeah, we just have some other negative prompts. and various parameters, which ultimately, without going into too much detail, and again, we're iterating through these as we work, are really just helping the model understand of how to transform the input video and output as a realistic result, and how much freedom it has, and whether or not it should be listening to like the color information that's presented versus just the canny edges. And so yeah, all of that's there in Omniverse, and yeah, we can't wait for people to get their hands on it and play with it.
It's pretty awesome. We have lots of great questions and comments about getting started. So, which I think alludes to the slide that I had up on the screen as a tease a minute ago. So let me show that screen again. Yeah. So how would people get started? What's the recommended first step?
Yes, so I think it's pretty easy, everything on the slide. But again, if you are a beginner, you don't know what we are talking about, you just want to give these models a run, then go ahead and go to NIMS, which is our NVIDIA Inference Microservices. Go on API catalog. The link is simple. It is build.nvidia.com, and you can find Cosmos models there. Add your prompts. There is already a prefetched prompt that you can see when you go on that page, and you can edit the prompt or provide a new prompt and generate a video output, which is more like a future frame or a simulated output. And then you can play around with it. If you are happy with what you are seeing on the screen and you want to use that in your real robotics and autonomous driving workflows, then I think the best places to go are NGC, which is our cloud repository for NVIDIA, but you also have it open on Hugging Face and GitHub repository. Good thing about these models, and I saw there was some trouble in accessing the link for Hugging Face. I think it's very simple. You can just Google search Hugging Face Cosmos collection, and you will land on this big collection of models for Cosmos World Foundation models. So go use those models, try it out with your custom workflows, or to generate just a simple synthetic video data for your models. And then you can also go to GitHub repository to access the fine-tuning code or post-training code that we are using NEMO frameworks, which what Josh talked about and walked through the entire process. So you can fine-tune these models using that code, and it's pretty easy. You can choose either autoregressive or diffusion model that you want to try. How these architectures are important, or what are the different techniques and benchmarks, you can read about that in the research paper that's also here. You can also search the Cosmos research paper with a simple Google search. So these are all the resources for you all to get started with. And I think a good thing about this is, because this is open, you have a lot of community support and people helping you out with your challenges and questions. So feel free to post it on our Discord channel, or to post it on Hugging Face community, where they should help you out with any challenges that you face. Yep. So if that's not enough, then I think we need to go to the next slide, which is our big show, GTC. And all of your questions get answered here. All the challenges that you have, everything you want to learn about Cosmos or everything about physical AI, you will get it answered at GTC. GTC is our unique developer conference. I think Edmar talked about it in detail at the beginning of the show. So do register at GTC if you want to be at the forefront of physical AI with your development journey. I think there are amazing labs and sections here. So I'm going to go to the next slide, just talk about key sessions, key resources for you to get started on Cosmos and physical AI development. We have an amazing talk from our research team. Our head of research for Cosmos, Mingyu, is gonna give an introduction to Cosmos World Foundation models. It has everything, all the meat that you want on Cosmos. So please register for this talk. Then we have really high-level talks on physical AI and some generalist robotics model. There are a lot of questions on how actually to integrate Cosmos World Foundation model in your robotics workflows for your actual robotic tasks. So I think the answer, and I'm going to give it a shot, and Josh can discuss it in detail later. But you can always fine-tune these models for your custom policy model, or custom robotics or autonomous driving use case, and then use some of these foundation model development platforms like NVIDIA GR00T to continue developing physical AI models. And these are some amazing sessions to get you started with those workflows and those downstream applications of Cosmos. Then if you have any questions, you've already tried Cosmos or you haven't, but you have a lot of questions, then me and Josh will meet you again at GTC in Connect with Experts with tons of engineering support, tons of technology and research support to answer all of your questions. So this is a Connect with Expert session, develop world foundation models with NVIDIA Cosmos. So we are excited to see you at GTC. But if that is not enough, we also have a synthetic data generation of Connect with Experts that will dive deep with you for generating synthetic data for your robotics task and robotic development. And then we also have a workshop between, you just saw Josh just walking us through an Omniverse extension and doing a bunch of stuff with Cosmos. You can do it too. So you can attend the training lab, which is an introduction to NVIDIA Cosmos for physical AI. That training lab will walk you through all the stuff you need to know about autoregressive model, diffusion models, and how to integrate your workflows and how to use these models. So a lot of exciting stuff for GTC, a lot of learning here. So make sure that you take a screenshot of this slide, or you go on NVIDIA GTC website, look for these sessions and register for those sessions. Yeah, that's
That'd be
super
amazing.
exciting.
So
Yeah.
obviously, you can't beat going to GTC, as we've been saying over and over again. And this is one of the reasons why, not only for these sessions, but able to ask directly to the NVIDIA developers and other people in the community. We have some great experts from the community. I actually posted a video someone had shared and created shortly after the announcement from Jensen about getting started with Cosmos. So I put that in the link a little earlier, in the link, live chat a little earlier. But it's also a great opportunity to engage with other members of the community. NVIDIA ambassadors will be there. Those are people who are experts in one or more areas of Omniverse from the community. I see Michael Wagner's in the live chat. He'll be there. Pekka Varis, who we is a little under the weather, so we hope you get well, Pekka, very soon. So best wishes on a speedy recovery. But Pekka is also planning to be at GTC. He'll be at the Dell booth, actually. I'm not even sure if I'm allowed to say what he's doing there, but he'll be showing us some really cool Omniverse stuff at GTC. Christopher Scott will be there. As Panjali said, we'll all be there. We actually have a few things happening in the community in terms of get-together. So that's why it'd be great to let us know if you're going. You could we have a channel on the Discord server, which is discord.gg/NVIDIA Omniverse, where you can just go to the GTC channel under the events category and let us know if you're going, so we can add your name to the list. It'd be great to meet you. It would be a great honor to meet and see how we can help you and your projects with OpenUSD and Omniverse. Okay, so let me see. Do we have any more questions that we want to tackle from the crowd here?
Yeah, I think we have a bunch of questions we can jump into here. So yeah, I think one question. Let me just start at the top here. Let's see. Can NVIDIA Cosmos be used to train autonomous robots such as AMR, autonomous mobile robot, for order picking in dynamic warehouse environments? And absolutely, that's one of the ways we'd love to see Cosmos used for those three use cases we talked about: synthetic data generation, policy evaluation, and also for potentially policy as well, where you initialize policy on Cosmos for your AMR. All right. I think I see the fine tuning amount question. We went over that. Will we do a video walkthrough of the Cosmos model, like setting it up and doing a demo with the models? Was that, Edmar, did I hear you speaking to like Mingyu? Or go ahead.
No, I'm sorry. I didn't know if that was basically posted after you kind of showed a little workflow earlier.
Yeah. And also I think on walkthrough, it takes a lot of time that I think you need to go to Hugging Face, select your models, what do you want for your use case. So I think it's going to take some time for you to find out what you actually want to use. And then you can go to GitHub to see the steps, to see the process. There is a good documentation available there. And I think then Josh also shared how it looks like with an extension. So that should pretty much be it.
Yeah. And the next question is regarding how do we use the Cosmos extension with Omniverse? That's not released yet, but it's coming. And more announcements will come soon with its availability. How can generate? Let's see. Where is the promised control net from Renan? So, yeah, we're excited to be talking about this control net today. It's not yet available on Hugging Face's GitHub, as you no doubt noticed, because it's not there. But it's coming at GDC.
There you go.
The video to world model has a number input frames option, but it looks like it only supports feeding the first frame or 9 of the input video, and that's correct because the video to world model that is available on Hugging Face is not a style transfer control net. It's predicting future frames. So by taking the first frame, which is basically an image, or the subsequent 8, which makes it 9, it'll use that and condition itself to predict the future frames. So it's a different sort of way to leverage the model. It's not a style transfer, it's a prediction of future frames. Let's see.
The previous question was from community member Papa Chuck, who's very active on the Discord. Great developer, so I highly encourage people who want to meet him and chat about this work. Head over to the Omniverse Discord, where he's a daily presence.
I think there is an interesting question on how can I connect Cosmos models with Isaac Lab. And so I think if you Google search, I have straight answer, but if you Google search Isaac Cosmos blueprint, we also have released a blueprint. We are working on this blueprint that actually teaches you how you can use Cosmos with Isaac Lab. So I think that's a good starting point for you to go and read through the blog and the steps. So Isaac Lab, as we know, is going to be a big workflow enabler for Cosmos for robotics training. So yeah, use the blueprint.
I see a question. How does Cosmos differ from Mega in regards to AMR? And Mega is Omniverse in a sense. It's built on top. It's and I'm probably not the best to speak to all of Mega's capabilities. I'm not the product manager for that. Edmar, I'm not sure if you've done a live stream on that, but ultimately it's very harmonistic. It's similar to what we were speaking to earlier, where if you position Cosmos on top of that stack of that workflow, you can leverage the style transfer function using all the work that you're doing in Mega.
Speaking, and this is a great question from a great person, John Mitchell. He works over at BMW, as you can see from his name, and he will also planning to be at GTC. So John Mitchell is another great person you can meet if you come. I know I'm looking forward to that.
That'd be great. Yeah, I'm sure all the Mega folks will be there as well. Maybe we can all get together and talk through it.
Yeah, I think I see a question from Data Juggler. Will we ever be able to create 3D scene or environments? Yeah, we can do that today. I think you can use Omniverse to generate these 3D scene and environments. Then these 3D scenes will be used as a video, as an input for Cosmos to generate a lot of photoreal videos. So to even help you out with generating these 3D scenes quickly, we also have tons of generative AI APIs in Omniverse, like Edify 3D. You can just simply prompt and generate a 3D asset in Omniverse and populate your scene and get started with your 3D scene.
Great question.
Same for Edify 360 HDRI. There is another API that helps you generate lighting maps, environment maps for your 3D scenes. So you can do the same. It's really quick. So yeah, use Omniverse for 3D scene generation.
There's also a question. There's no documentation on the data structure, such as the proper encoding for images and videos and the label. I think all of this will come along with the GDC release and associated announcements.
Great question. Yeah, so some of this actually is and some of the live streams we're doing the next couple of weeks are kind of a preview in a way to some of the great stuff we're being announcing and showing off, releasing at GTC, a little over a month away. So, but again, we have that great channel and Discord server for GTC related stuff. So feel free to post there. Or we actually just created a channel earlier today, thanks to my lovely guests here, for Cosmos in the Omniverse Discord server. So. Feel free to jump into that channel. We'll post that link in the chat.
I see a question pin. Cosmos enhances the training, and it also reduces the overhead engineering you would apply on making simulations. Absolutely. I think that's exactly what it's helping to do. So that's a great point to call out.
Wise words from Papa Chuck, as he is known.
I saw, can you self-host it? Is it open source? Cosmos is open source. You can pull it down as on this slide here that you see on the shared screen. And yes, you can host it on your own PC or on a cloud infrastructure.
Yeah, and sorry to interrupt. You can complete your thought, Josh. But I also wanted to call out DGX Cloud, which is NVIDIA's cloud for deploying your models, and DGX Cloud work with a lot of public cloud provider. So I think if you don't know about it, just Google search, read about it. NVIDIA DGX Cloud is a great place to start with deploying your World Foundation models.
I think there's some really great technical questions here, such as, how do action tokens work in Cosmos, or what is the process of using Cosmos videos to implement robotic tasks physically? And I think these would be great to follow up with if we have Ming Yu or another research lead dive into maybe some of the light deep dive type environment of how to actually do these in some practical scenarios.
Yeah, we'll go ahead and set that up. Ming Yu's in high demand, obviously, right now. We'll do our best to bring him on. But that's definitely, these are going to be ongoing sessions. So not only do we do these weekly live streams, if you're just joining us for the first time, every Wednesday at this time, we also have 2 study groups that are happening that are actually managed and led by community members. We have the OpenUSD study group, which is on Tuesdays, and then we have the Isaac Lab study group, which takes place on Wednesday. But you can always bring up other topics in those study groups because there are other OpenUSD users and developers that are there, and I'm sure they'd be happy to talk. I know a couple of weeks ago I was there. We were just chatting for 3 hours on a bunch of different topics. So it's a great place to get together. That's on the voice channel on our Discord server, so everyone kind of just hangs out and chats shop.
I see one more from Aliza. Can it be used for self-driving training and metrics? Absolutely. Yeah. Autonomous vehicles, self-driving is where we're hoping it can be, it can be leveraged by various partners and community members.
By the way, if you have a great project that you're working on, or maybe you like doing little tutorial videos, let us know if you produce something and are doing something on LinkedIn or YouTube, so we can also share it with other members of the community. We've been seeing just a lot of great training content produced by members of the general public. So we definitely want to highlight and promote those people doing that great work. So let us know if you are doing something, and we can try to boost awareness of it.
And I think a lot of detailed technical section we want to have Ming Yu for those sessions. But if you are really interested, I think the research paper is a tad bit long, but it's still a really great resource, a great place to dig through and find answers to your questions, whether it's for token generation, for tokenization, labeling, filtering data, and all those sort of stuff. So it has all the good details that you can. And it's not that long. It's just 50 pages. So
and as you said earlier, we also have the GitHub and Hugging Face repos where we posted this, but they also have their own associated forums, and we do look through the forums to see the conversation and see the signal and look at where people are encountering questions or having issues. So that's a great place to post any questions that maybe you need for follow-up.
Great call. Okay, we've got about 5 minutes left, so definitely want to encourage everyone to continue posting your questions, your comments. We'll do our best to answer these in these last few minutes of the live stream. On the screen, I'm just showing some of the sessions happening and some of the great people that will be speaking at GTC next month in San Jose, California. Lots of stuff on physical AI, obviously, and robotics. And we have different tracks. So depending on what you're interested in, we're going to be posting some sample schedules, I believe, on our social media and our Discord server. Look at some of the sponsors here. But GTC is a Woodstock of AI. That was what one of the attendees said. I don't know who that was, but I can see it. All right, cool. Any other questions that we see here in the chat that we want to tackle? like I said, the conversation does not stop here. You can jump over to the Discord server and chat with not only NVIDIA developers, but also some members of the community who engage there very regularly. It's very active. So I'd like to see this new Cosmos channel. I want anything question you don't have that was you didn't you asked but was not covered today. Maybe you didn't get a chance to ask. Please let us welcome this new Cosmos channel with some great questions and comments. You can just start a post on your own anytime, day or night. Of course, if you tuned in the second half of this live stream, you missed the first part. The live stream is available right away in its full glory on YouTube. So you just go and hit rewind, and it's there. And it's all of our live streams are available on the YouTube channel for NVIDIA Omniverse. You just go to the live section, and then you'll see all the live streams there. Josh, how do you feel? Your first live stream done, one and done. Now you're gonna be here every week now, right?
Absolutely. It was so exciting. Thank you so much for having me.
It's fantastic to have you. Josh and I go back a ways from game developer days. We both worked on a couple of great games from THQ back in the day. So
An age ago, yes.
It was. I know. Before our kids.
Yes.
Our kids. Okay, cool. I see a question here about the launcher. So in the last couple minutes, we recently launched the launcher's being deprecated, and there's nothing to be scared about or worried about, actually. It's pretty exciting. The launcher is not needed for people to actually access everything. The Omniverse has always been a development platform, of course. There are on the Discord, we're showing people different ways to access different things depending on what you're doing. But the idea, obviously, is that people are building their own apps extensions on top of Kit or otherwise, and leveraging Omniverse for your own apps. And it's pretty simple transition, and actually things will actually be loading up quicker and stuff without the launcher for you. So nothing to be too worried about there. It's pretty straightforward. Our community team, Richard especially, has been very active trying to help people on Discord, figuring out how to do things without the launcher. But the launcher still works today, so it's not gone yet. Okay, any more questions that we see here? Let me see. A big thank you to Amelia, who's been managing a lot of the behind-the-scenes posts, links, and resources. If you missed anything, we will update the video description, but also you can watch the live stream and scroll through the chat, which should always be available. Let me see if we have any last minute questions here. How do I ask an Omniverse question now? Data Juggler, feel free to ask an Omniverse question. Feel free. We'll if we can take it now, we can take it now. Otherwise, you know where to reach us on Discord. Yeah, there you go. I'm going to put this on the link. I always get in trouble for this because it's so ugly looking, but I'm going to put the Discord address on the screen in a very unfriendly manner. So here you go. If you need to know where to go, this is this is the Omniverse Discord server address. Oh my God, I feel so bad. The marketing team is curling up in their chairs right now. Okay. All right. Let me see. Painted green. I should paint that green. That's true. No, we should never show that banner. I think I was forbidden to show it last year. Okay, cool. All right. So I think that's it for the questions. So I want to thank Pranjali and Josh, both of you, for coming on with this great presentation. I hope everyone out there watching, we had hundreds of people watching. Thank you for joining us today. Really exciting to see all these people interested in Cosmos World Foundation models for physical AI development. We went over how OpenUSD is leveraged, how to get started, how the foundation models actually work, and just some ideas of different various uses that you can do with them. Obviously, physical AI is a very exciting thing across the world. You're going to see a lot more about it at GTC coming up. We hope that you will join us there. Let us know if you're going. Again, we posted a code earlier which gives you a discount for attending GTC. If you missed it, feel free to ping me. You can reach me, edmar@nvidia.com, or on Discord, edmendi, EDMENDI. I want to thank, again, Pranjali and Josh for taking their time and preparing the presentations.
Yeah, this was fun. Thanks for having me.
Thank you so much.
And thank you for everyone out there watching. Great questions in the comments. Really appreciate it. Until next time, we'll see you on Discord, on the forums, on GitHub, on Hugging Face. We'll see you everywhere out there. So thanks for joining us. And if you want interested in the Isaac Sim and Isaac Lab, there's a study group happening, I believe, at 12:30 p.m. Pacific, which is 30 minutes from now. So hurry, go take a quick bathroom break, and then head to Discord for the study group. And thanks again to Amelia for all your help on the marketing team on promoting everything we did today. Until next time, see everybody soon.
Bye.